David, thanks for being here.
Yeah, excited to join you.
Yeah, really appreciate you taking the time to have this conversation and share some of your experience.
Yeah.
So, maybe to get us in, would love if you could just tell us about your background, introduce yourself a little bit. How did you decide that you wanted to become a mechanical engineer?
Yeah, so my name is David. I decided I wanted to be an engineer because I really like math and science more than reading and writing, like many of us. And a mechanical engineer because I really like physics more than memorizing note cards of biology and chemistry. So it was a natural fit, and I've just found it to be a very fun and fulfilling career. So I went to school at University of Wisconsin-Madison, and I've worked in automotive test and cell phone cameras at Motorola, and now at GoPro doing action cameras. So
Awesome, thank you. And how have you seen, either firsthand or based on your experiences of talking with other people that you've worked with, how have you seen manufacturing change, either over your career or from generation to generation?
yeah, it's funny you should ask because my grandfather, my father, and I all have the same degree in mechanical engineering from the same university at Wisconsin. So when we compare notes about our careers, my grandpa was doing things on slide rules, and now I'm using AI to optimize manufacturing. So, now we just have an abundance of data and tools and CAD and FEA and all these programs to design and manufacture consumer electronics or any part that you're designing. So we have an abundance of tools available to us, which is great. It makes optimization possible and doing things at the real bleeding edge of physics and technology. But then if we compare notes back to my grandpa's generation, they sent people to space, and they did really cool things with just first principles engineering fundamentals. So what you can't do is rely on these tools too much. You have to also know your fundamentals and do things the right way. So yeah.
What is, out of curiosity, what is your grandfather or your father think about what you're doing now and the tools available? Do they have a perspective on that they've shared?
Yeah, my dad thinks everything I'm doing is very cool. He's a user of GoPro products, and just in this industry, every micron matters. Whereas the industries that they worked on, we didn't have quite so much precision tolerances and requirements. So yeah,
very cool, very fun. And you're obviously an engineer, mechanical engineer, working on the engineering side of the organization that you've been a part of. How do you see, at least in our experience, we've often seen a tension between engineering and operations. Is that something that you've observed? What are your thoughts on that?
Yeah,
coexistence?
Certainly there can be tension between ops and engineering. I think we've all felt it, especially in crunch time of trying to launch a product. But I think what's most valuable is developing relationships with your counterparts. You both have your own goals and your own, the things that you care about, but developing really great relationships and trying to achieve both of your goals at the same time is really paramount. And it goes a long way when you see yourselves as friends, not enemies. Yeah. You can work together and do each other favors and get to the finish line together.
Is there an example or a way that you found particularly effective at building those relationships across the aisle, so to speak?
Yeah, I think ops can value engineering getting into Asia and sitting at a conference table together and hashing problems out. I think you have to empathize with each other's position and get together and hash things out together. So if you're just pointing fingers or emailing or acting as enemies, then you're not going to get anywhere. So
so face-to-face time.
Yeah.
And maybe going that extra mile to build that empathy.
Yeah,
great. Yeah, makes a lot of sense. And you've obviously brought many products to market, have a lot of experience throughout the NPI process, the new product introduction process. And out of the places that you've worked, what stands out as the best NPI process?
Yeah, when I think back to my time at Motorola, I remember it being kind of a well-oiled machine.
Motorola is well known for their NPI. Yep.
They have the right processes, the right people in place, and they benefit from a lot of products. So when you're churning out many products a year, you have a lot of time to iterate and learn from your mistakes and optimize. And the challenge I see at other companies is when you're doing fewer products or new products, it can be challenging to kind of encompass the entire NPI phase and have good control. So I think just a lot of forethought and developing a good NPI, getting the right people and the processes in place, and acting like it isn't your first time.
Can you give us some, there are two parts to that that I think are interesting. Could you give us some examples of those processes or those practices that stand out at Motorola? And I'm curious in particular how having so many cycles to iterate actually feeds into that and makes that better.
Yeah, I think, it's attention to lessons learned. So not repeating mistakes. It's
What does that look like literally? Is it a checklist? Is it a example? We have like this long checklist of here's every mistake we've ever made.
yes, I'm very passionate about JIRA checklists, gate exits, gate entries, and a lot of good documentation, crossing your T's and dotting your I's, and just not missing things, and having the right controls in place. Because if your product can fail because one person does something wrong, it's not that person's fault. It's a bad process. You need the right checks and balances and the right checklists in place.
Great. Yeah, that makes sense. Yeah. Anything else on that front? Anything that like either you brought with you from Motorola to your time at GoPro or otherwise that you would recommend to folks?
Yeah, I brought JIRA
Brought your
EDP checklists. Yeah, that's something that I'm working hard to implement. So yeah.
Fantastic. Great. And I guess maybe notable, JIRA is not just a software engineer's tool anymore.
Correct. Yes.
That's something that we see as well.
Yeah.
What do you think is most important in an NPI process? What do you see as either whether it's like your timeline, those phase gates that you mentioned, what stands out as the most important?
Yeah, I think, timelines are always a challenge, but trying to set yourself up for success. Set yourself up for success with good checklists and good JIRAs. Set your vendors up for success. Oftentimes when you fail, it's easy to point fingers, but if you have time to reflect and ask yourself, why are things not going well? What can we do better? And I think, like I said, with interfacing with ops, interfacing an NPI with your vendors is just getting overseas, putting a smile on your face, shaking hands, and developing a relationship. Everything will go smoother after that.
Yeah. Do you have advice for folks who are maybe in those NPI stages, maybe they don't have a ton of NPIs under their belt? What are those must-dos? You mentioned a couple of times traveling to the factory and having that face time. When do you recommend people do that? What cadence is important for that?
Yeah, I think oftentimes you neglect the early visits. The early visits are a great time to give a vendor your requirements, talk through your reliability templates, your IQC templates, gate exit templates. If you skip those and then you find that your builds aren't going well, it's often because the vendor tells you, oh, you didn't tell us your requirements. And so I find that the early visits are often the most valuable. You're less stressed, which helps. But getting out ahead of the problems is really important.
Great. You mentioned gate exit templates a couple of times. Can you just expand on that just just because we're talking about build exit criteria?
Yes.
Yeah, what goes into that you think is really important to define?
I think it's important to not let things snowball. So if you're going to exit a DVT phase and you've got issues from your EVT and it's only hopes and dreams that are going to make those issues go away, you're not set up for success in DVT, and then your DVT becomes an EVT. So it's really important to stop and reflect at the end of builds and ask yourself what's going well, what needs improvement, what can we iterate between this build, and do better going into DVT.
Great, thank you. Just to double check, are we okay on audio? Everyone can hear us? Great. And it also sounds like getting in early, right? Having these maybe before stuff has hit the fan.
Yeah.
Is really helpful. What else is important about sort of how else can we be proactive, either in that factory communication or I think that stitch in time is really interesting concept. Where else do you apply that?
Yeah, I think going back to kind of setting your vendor up for success. So giving them your requirements early, automating tasks. Let's make the easy things easy. If your easy things become hard, you're not going to have time to make the hard things to get past the hard things. So what I like to do is generate a lot of templates that just automatically look at data and judge your data. It helps the vendor know what your requirements for them are. And just a lot of communication, a lot of setting up your vendor for success is paramount.
And when you're saying look at data, do you mean IQC data? Do you mean final test data?
Yes. So IQC data is a good example. A lot of IQC data is generated, but who has time to go look at it and judge it and grade it? And so if you have a template that's just, you've got conditional formatting and rules that the vendor can input the data, and if there are red flags that pop up, they know right then that there might be a problem. But if you've just got, oh, send me your IQC data, I'll look at it in a few weeks. That's not a recipe for success. So
in an NPI context, way too late.
Yeah.
Got it.
So it's an example of setting your vendor up for success.
That makes sense. And when we're talking about vendors here, are we talking about FATP and your primary CM there? Are you talking further upstream?
All of the above, yeah. Every time you have a relationship overseas, they need to know what you expect of them, and you need to make the easy things easy.
Great, yeah. Thanks for the insight. And I guess one of the main topics of this conversation, we wanted to talk a little bit about designing for instrumental. And this is something that I think has come to you as you've gone through not just the NPI process, but the NPI process now with instrumental in a couple of different contexts. Is there a specific experience that has motivated this idea, that has caused you to consider designing for instrumental?
Yeah, I think, when you're developing a product in NPI, you encounter issues, you see things on instrumental, and you ask yourself, oh, I wish I did something differently in the design phase where it was inconsequential. And that could help me use this tool better. And so, we've been kind of brainstorming together about ways to design for instrumental. And so we're excited to share some of those ideas.
Great. Is there an experience that jumps out, if you can tell us about
Yeah.
it, where it's like, man, I wish I'd done this thing?
I had a product one time where the thermal solution could easily be flipped upside down, and then it didn't work because your thermal path was going the wrong direction. And there was adhesive on both sides, and both sides of this part had liners on top of the adhesive, and the liners were blue. And so the operator, the part was very symmetric and easy to flip, and both sides were blue. And so it was just an automatic idea to just, let's use a red liner on one side. And then in instrumental, we can set up a monitor to detect blue liner or red liner. And, had we thought of that earlier, it would have made that build go easier. And so it's just an easy flag to flip in your drawing to make things easier on yourself later.
Got it. And maybe it's worth taking a step back just to help define what do you mean by designing for instrumental? What are the is that just designing for inspection? Is it broader than that?
Yeah, I think design for instrumental and inspection go kind of hand in hand. But the instrumental platform is very flexible. And so it doesn't need as much forethought into what can I do in the design phase to make this, to allow me to test this product. But with a camera and instrumental, there are certain things that you can do in the design phase to make the camera more valuable. And so when I think of instrumental, and maybe you can fill us in, but we're talking about visual data in the cameras right now. So RGB, textures, brightness, that's the data that's being fed into the camera. And I know you worked with Apple, so I don't want to offend you, but a lot of Apple products are black inside.
Absolutely.
And sort of featureless.
Yeah.
So what are your thoughts on are you using this platform, are you looking for more texture, more color, more features? Is that what would help your system?
Yeah, that's a great question, great point. And I think you're right that a lot of it comes down to designing for inspection, where can we make meaningful differences visually different as well. I think that's a great starting point. I think there's also a question of what other data can we feed in to make the images more valuable. Feeding in functional test data that you can connect and tie those together. And so there's maybe even more holistic approach. There could be a more holistic approach.
Yeah, especially when you're talking about marrying data from your test systems to visual data. There's just, the possibilities are so endless.
You bring up a good point about Apple products in particular, and guilty of this as well. Maybe this is driven just by Apple, and maybe Apple plus the fact that everything ends up on iFixit teardowns. The inside of products, a lot of times people are trying to make those just as pretty, almost as pretty as the outside.
Yep.
That drives, black on black interiors and so on. How do you think about that balance? How would you recommend people approach that trade-off?
Yeah, I mean, Apple is a unique company with a lot of products on iFixit. And I'm not sure that all of us in the engineering field adhere to those same principles. Certainly it's not something that's top of mind in the industries that I've been in or the companies that I've been at. And even more so when you're talking about using an instrumental tool, maybe it's time to deviate from that and really enrich the data that can come out of the inside of the product.
Got it. So maybe a very narrow slice of the consumer industry or the slide.
Yeah.
Great. Yeah. Maybe this is a great segue. Or maybe as we segue to the brainstorm, are there specific things that you do look to modify or that you could modify for in order to design for instrumental?
Yeah, I think in the design phase, like I said, it's pretty inconsequential to add some things. I'm talking about part colors, adhesive colors, silk screens, laser markings, tool markings, cavity markings. Your molder or your vendor for any subcomponent isn't really going to balk at any of these little flags that you put in, but they need to be put in early because they're part of tooling. So as I design products, it's definitely something that I'm going to be thinking about more, is where can I put little Easter eggs and little flags inside of this device to help me out in the future.
You talked about, I think those are a lot of examples relating to part design, which is great. Does that extend to assembly design as well? Are there things that you think about either how things get assembled, the order that they get assembled? Does that contribute as well to your?
Yeah, I think, as you're looking at DFA at your CM and you're thinking about instrumental stations, you really need to think deeply about what's important, what kind of data am I supposed to get out of this tool, and what am I going to be really thinking back and wishing that I did differently when I get into EVT and I don't have visibility into, is my light pipe aligned to my LED or something like that. So and this goes into kind of DFMEA is what can go wrong in this product. And I think the key with instrumental is detectability. If you can keep your detectability score low, your DFMEA looks a lot better. And
detectability score low, meaning a high chance of being able to detect.
Correct. Yes.
Yes.
Yeah. Yes. High chance. So I think that's what you're looking for in your CM is detecting quality issues and not letting those leak into the field.
Great. Should we put this into practice? Should we take a look at a real product and see how we might improve it for design for instrumental context?
Yeah.
Awesome. I'll ask you to drive if that's okay.
Cool.
Full disclosure, this is not one of David's products. We're going to show a demo product, and we'll see if we can get this pulled up on the webinar here.
All right, we should be live.
We all good, Sarah? Great. So let's orient ourselves a little bit.
Yeah.
This is not a GoPro, but it is an action camera. It's a 360-degree camera. This is made by Rilo, and these are images captured at instrumental stations at I believe 4 or 5 different places along the assembly line, capturing several different images of the product as it gets assembled. And so you see those images along the bottom here, where we can essentially step through the unit as it gets built up from the top plate inside and outside, the board being assembled with that top plate, the main housing assembly with its board and lens assembly in there, as well as the finished good inspection steps. And so maybe we dive in here and is there a place that you'd like to start in terms of types of changes that you would make from a design for instrumental context?
Yeah, when I looked at this product, I actually thought that they did a pretty good job let's talk about just the most obvious thing and just a really cool way to use instrumental. One of my favorite things is just to go in and circle a region of interest and say most recent, and that's just going to bring up the most recent data. And like here's an example of this isn't rocket science. You often put silk screens on FPCs and look for misalignments, and this is something that could be caught with instrumental, but it can be caught because you put kind of an Easter egg in there, and you have a silk screen to look at visual data off. So this is an obvious one that would always be there, but it's just a good example to get us going.
So that's maybe a good starting point. Where else? And I think that's a pretty common place for people to put a silk screen marking for exactly this purpose, whether it's using instrumental to inspect or an operator to inspect for zip insertion. Are there other places where you would maybe add markings that are less common for the purpose of instrumental or other?
Yep. Yeah. So another area that we might be interested in is like LED to light pipe alignment. It looks like this light pipe is heat staked. You've got a PC board down here with an LED on the lower left, and this pipe directs the light into kind of a bar LED that goes outside the product. And alignment is usually critical between these components. I'm not sure if they had any alignment issues with just the way that they've constrained this part, but it would be pretty inconsequential. And I've done this in similar locations to just add sort of maybe some centration marks in your injection molded tool. So your molder during tooling phase could just add some center lines, and it's very easy in the instrumental app to just go through and you might find that sometimes your light pipe ends up here, and it's obvious because you put a centration mark in.
Just to be clear, we're talking about molding on the black housing there.
Yes, yeah. Which in this case is obscured by this this copper piece, but it's a good example of in your housings you can be putting. It's kind of like in an auto shop when you pull the drawer out and there's a spot for every wrench in the drawer. This is kind of how I envision enriching this visual data. It's just, are my parts aligned? Are they going in correctly?
So that is one piece of the tolerance stack, right?
Yeah.
Obviously, like light pipe to LED is a pretty long tolerance loop, including registration to the housing here, but also then housing assembly, and LED position on the board tolerance to the housing as well.
Yeah.
Are there other ways that you might think about instrumenting that loop?
Yeah. In your final finished good test, oftentimes you'll put an LED test to test LED brightness. And if your LED brightness is very low, you're going to catch it there. But then you have to tear open your device and rework it, maybe scrap some components because they got destroyed during rework. And so what you want to do is not only detect issues, you want to detect them as far upstream as possible. So if I can detect in this assembly step that my light pipe is misassembled, I can go take off this light pipe and put a new one in. Of course, it's heat staked, so that complicates things. But at least then I haven't carried these bad parts all the way to snap and finish final assembly.
Maybe worst case, you're reworking the top plate instead of reworking the whole unit.
Yes, yeah. And so, if light pipe assembly was critical and it was an issue, it'd be very hard to detect this issue without some sort of inspection. And you can have an operator inspect every part, but then you're relying on an operator's eyes and whether they had coffee that day. So it'd be really nice to just automate this inspection.
I think you raised another good point, which is at the end of the day, measuring that like LED brightness and using that as ultimately your no go. In this example project, I believe they actually did pull in LED brightness data. You can actually use instrumental to correlate between LED brightness and either visual shifts of the light pipe or other visual shifts of the LED, shifts of the gasket around the LED. And that's a way that I think customers also use instrumental to, if they do have a problem with this LED brightness, hone in on, test a bunch of root causes, either eliminate them quickly or hone in on what might be the root cause.
Yeah, and it's really important because you could be sitting in an engineering meeting and you've got bad finished good light pipe data, you know your light pipe is assembled. Are those two correlated? And that's where tying this visual data into a final test metric would be so valuable, because if you knew that because your light pipe is misaligned, that's the root cause of your poor light pipe performance at finished good test, then I can just say, okay, I'm going to improve this alignment and be done with it.
Yep.
But if they're uncorrelated, then you have another issue. Maybe you have a smudge on your LED, or an operator knocked the LED off, or something else. So it's important to do correlations, which is one of the valuable items I see in instrumental.
Great. Let's keep going. Let's jump back to maybe some of the more interesting parts of this product.
Yeah, so, if we again just look at kind of what they've done well, we've got cavity and part revision markings visually in areas that you can see. If this laser engraving had been buried in the product, you would never know. So is your CM mixing parts up? Are they installing a Rev A to a Rev B or something like that? So traceability is one thing that Anna in her Build Better handbook is always talking about, and there's so much value in traceability. And one of my pet features for you guys is character recognition, to be pulling cavity numbers and silk screens and laser engravings into the tool, and maybe doing some correlation or some testing on that. So
Great. Well, you have our ears.
yeah. But in other areas, one thing that struck out to me was this microphone gasket. And if we look, there's a lot of variability in this microphone gasket placement.
Yep.
And one thing, the gasket's black. Does it need to be black? Maybe it could be red. Silicone colors are very easy to manipulate. So oftentimes I've found that are they forgetting to install the silicone gasket cover, or are they forgetting to install the O-ring?
Yep.
Does it need to be black?
I bet we can find some. I bet if you just we have it turned on, maybe not in this demo, but I bet there are some here that we'd be able to find. Or
Yeah.
Even some contamination that might
Yeah.
work.
Here's some contamination. So I like that they put the white dot in, and maybe that was their detectability kind of Easter egg, is look for this white dot. And so again, this product was pretty well designed. I see that some are missing the white dot, so I'm not sure what the story is there.
Yeah, I'm not entirely sure what that white dot is. That's a great question.
But just like LED to light pipe alignment is critical, your microphones are very sensitive to alignments of gaskets and PSAs. And so this is something that maybe I would like to improve, is improve the design, improve the detectability with the tool. If I look at another position on this, in this microphone region, I can look at the PSA that surrounds this mic port. And oftentimes what you'll see is that your PSA is partially covering the port. So does this PSA need to be black? Does the surround need to be black?
I want to pull the wisdom of the crowd on this one, actually. If folks are watching and have an opinion on the notion of black on black parts, black gasket on black PCB, black foam on a black housing front, is this avoidable? Is this unavoidable? I think this would be a great thing to get broad opinions on it.
Yeah.
If folks have thoughts that they want to share in the comments.
Certainly there are material constraints. Your suppliers may not also always have good lead times on alternate colors, or even the ability to make an alternate color. But there's multiple materials in this assembly. I'm sure you could find some location to switch a color flag and enrich the data.
The risk here, I would imagine, is, well, if that foam were to ever show, you wouldn't want it to be a bright red spot in your microphone port. But
your audio engineer would say, if that's showing, my microphone isn't working. So
that's true.
You can go back and forth on this.
It's great. Yeah.
We were also riffing before this on adhesives, and how you can, if we kind of look at this camera module, certainly this camera module is going to have a ton of adhesive gluing optical parts down to PCBs and elements into the barrel. And in certain locations, it would be interesting, because you've got a black housing and potentially a black PCB, to add color to your adhesive. your adhesive vendors can do a lot of custom things. They can add white dye, they can add fluorescence.
Yeah.
Have you ever put a UV light in your station?
Yes, actually, our customers do that all the time.
Good.
For exactly the reasons that you're talking about, which is where did my glue end up?
Yeah.
And so, yeah, we'll deploy a station with a UV light, often a visible light and a UV light. And so you might want to take a photo under each
Nice.
under each spectrum.
Nice.
And yeah, that's super helpful for whether it's glue or like the thermal coating, making sure that that ends up where you want it at, you know, whatever stage of the process.
Yeah. I need to try that. I'll ask you guys about that on my next station. Bring up.
Great. What else we dive into? What about connectors? So we talked a little bit about the ZIF connector. And that was on the backplate photo, I believe.
Yeah.
Here we've got, it looks like a couple of, at least 2 or 3 board to board snapped down.
Yep.
Is that something I'm guessing you've had plenty of experience with, that you thought about in a design for instrumental context?
Yes. So design for instrumental and design for inspection and assembly is very similar in this regard. A lot of times you're putting silk screens to surround the stiffener in this board connector, so that the operator can see where is the connector and am I aligned before I press? Because if I press when they're misaligned, you might damage that very, very small 0.2 pitch connector. And in this case, I'm sure that they do have some silk screen, like you can see this corner here, although that might be a component. But the actual station where it's capturing the image, it's obscured by gaskets to make sure that those connectors are pressed down and maybe some thermal solutions. So what I actually don't like here is that I can't see the connectors mated. That's just something super common that we see, is that you've got a device that won't power on, you look back at the instrumental data, and sure enough, that connector is just slightly unmated. And one of the good ways that I've found to detect that is oftentimes you have a stainless steel stiffener here, which is metallic and shiny. And if this is, propped up at an angle, it's going to reflect light differently. And that stiffener might then appear very, very bright. And we've been successful in training monitors to detect that. So it's valuable because, again, if you don't detect that your connector is plugged in until your final test, when you've glued a device shut or PSA'd a device shut, it's too late. You need to detect that sooner. And these connectors can be very tricky in nature, finicky. They might work before you've snapped the product, but once you've snapped the product, that misalignment caused some fallout. So
yeah, one other thing that is common when we have customers that are concerned about connector installation, we might either add an additional camera view or even install a mirror to give a sort of side view of that connector for exactly that purpose.
Yeah.
Make sure that's seated all the way.
Yeah.
I wanted to interrupt with a couple of questions that we've been getting from folks watching the webinar, if that's okay with you.
Yeah.
Would love to start by understanding what products do you think it's more obvious or most obvious to leverage instrumental versus products where it's less obvious to take advantage of instrumental, to design for instrumental?
Yeah. In terms of leveraging instrumental, again, often these consumer electronics are assembled by hand, so it's susceptible to human error. If you've got a very, very well controlled automated process that has good CPK and no fallout, then maybe it's a little bit less critical to have so many inspection steps. But whenever you have the opportunity for human error, or like a glue dispense can be tricky, or component placements, that's when it's really valuable to add these visual checks. So I don't know if I could pin it down onto a specific type of product, but if there's ever a part or process or product that you're concerned about variability and fallout, I think it's a great opportunity to insert this tool.
Great. And one other question that we have from folks is the relationship between the brand, GoPro or Motorola, whatever it might be, and a contract manufacturer. And in particular, does adding instrumental and sort of the visibility that instrumental provides, does that create tension? Does that create conflict?
Yeah, I think anytime you're implementing a new tool or a new process, there can be pushback. you've got people, oh, the way that we've done things works, and it doesn't need improvement. And oftentimes, if you can get past that hurdle and insert a tool like Instrumental, people immediately start to see the value. And I haven't seen too much pushback initially with the CM, but once we've had this tool and you can collaborate with your CM in this platform, I've found that they actually enjoy using the tool. So one thing that I love to do is, let's say maybe not in this particular unit, but I see that this microphone placement is wrong. I can go in here and comment, and I can tag my CM. I can tag my CM or my TPM and say, hey, why is this gasket not aligned? And they'll get an email, and they can just immediately go to that unit and see what you're looking at. I think oftentimes navigating across language barriers, we can all see things. So I've had so much success in showing people images of defective products, GIFs of defective products, as opposed to writing a long email saying this product is defective. So collaborating in this tool, I find there hasn't been much pushback with CMs. I think they value this.
So maybe just to be explicit, have you had an issue with CM being defensive about like, hey, we found this issue, and maybe?
I don't think so. I think, we're all striving to build good products and get to ramp and MP. And, when you've got critical issues in quality, that's going to prevent you from going to MP. So I don't think anyone's inclined to bury issues or get defensive about issues. And this goes into relationship building. We're all in this together.
Great. And again, you've used Instrumental at a couple of different places. How do you get buy-in from your leadership or convince your leadership to invest in a tool like this?
Yeah, I think, like I said, half the battle is getting started. And once you get started, the value to me seems obvious. And so oftentimes my leaders at various companies have been committed to quality, committed to being bulletproof. And so it's a good time to propose to them, okay, are we committed to quality? Are we willing to implement a tool and investigate the ROI? So it's a good time to confront your leadership when they're going off about improving quality.
This is putting your money where your mouth is.
Yes, exactly.
Yeah. And maybe just as important as getting leadership to buy in. And I think, Barry, within there, you made a great point about like, we demonstrate the ROI, can we show the value? Because ultimately quality is great, but needs to be a worthwhile investment. That's something we think about a lot and help our customers with a lot is how do we not just show that it's improving quality, but delivering value with that, saving money, delivering insurance. But just as important, and maybe even more important as getting initial leadership buy-in, is how do you get your team bought in? How do you make sure that that this value gets taken advantage of? That you have engagement there.
I think it's a lot easier to be bought in when you see the value in something. And so if you can get your individual contributors or anyone working in these tools to find an issue and demonstrate that issue and improve it, like that's just such a good learning experience to be like, oh, I saw a bunch of value in this. It made my life easier. So there's been tons of instances where, this tool has saved me flights to China. It's saved me hours and hours of building more units or scrapping more units or doing DOEs. And so it goes back to ROI. It becomes obvious that this is good data to have and a good tool to have.
How have you shared those lessons then with your colleagues, or how does it translate from you getting value to your colleagues seeing that value?
Yeah, I think, we can be sharing our wins with our team members, but then also setting them up for success and setting them up for wins of their own. So if somebody's got an assembly, sometimes it's finding a win if you're more engaged in the tool than they are, finding a win on their side.
You've got superpowers that they don't have.
Yeah. See, I can find this awesome data, or, like I said, I've been in engineering meetings where we're talking about an issue and everyone's, just racking their brain about what's going on, and you can share your screen and go into Instrumental and see this part is misaligned. And you said this product was good, but you know, I can see visually that it's not good. And so demonstrating value, setting people up for wins.
Great, wonderful. Anything else that we should wrap up in our brainstorm before we move on here? Is there any other either issues that you would like to take a look at, or the crowd would like to take a look at?
No, I think we've covered a lot.
Great, yeah. Well, thank you so much. Really appreciate your insight both into your process, your experience with instrumental, your thoughts on how you can use instrumental in the design stage to be more successful. Yeah, really appreciate you being here and spending the time with us. Cool. All right.
Yeah.
Great. Thanks everybody for participating.